Okay, so the last part of our rational functions unit is solving rational equations. So everything else is a rational expression. So to have an equation, you require an equal sign. And when you solve them, that means you're actually going to come up with a value. So when we're dealing with expressions, we're always simplifying them. And the instructions are always going to be simplify. And it's not a new cough. And in solving, we're going to solve. We're going to find the value of x that makes this true. Or the value of x that makes this true. Okay, how do we solve? We factor all of the denominators completely. Don't worry about the numerator. So in that respect, it's very similar to adding and subtracting. State the restrictions. Now this is very important because maybe one of our solutions is a restriction. So we need to check back against the restrictions. Determine what the lowest common denominator is. Okay, so far again like adding or subtracting. Now here's where it gets different. Multiply both sides of the equation by the LCD. And so by both sides, like up here, that would be these three terms. This term, then this term, then this term. And same here, that term, then that term, and then the zero. Although multiplying the zero isn't going to have any huge effect because that would still be zero. Simplify each side of the equation, solve the equation. So at this point, there won't be any denominators. So you'll be looking at a linear equation or maybe a quadratic. Solve the equation and verify that the solution satisfies the original equation. Solve the the equation, linear or quadratic. Verify the solution satisfies the original equation. Also, if there's a context to this problem, so say we're working out an area or something and we get a negative value for the width, then we know that that will not satisfy the conditions. Okay, so, and verifying also means that you're going to look back at the restrictions. Make sure that your solution is not one of the restrictions. So, like that negative width, an extraneous root is a solution to an equation that is not permissible in the original equation. Okay, so basically it's a restriction or a non-permissible value, right? So you get an NPV or, depending on how we phrased it, or a restriction. An inadmissible solution is a solution to the equation that is permissible in the original equation, but is not valid in the context of the problem. So let's say you're solving for an amount of time and you get a negative value for time. That may be permissible in the original equation, right? It's not a restriction or a non-permissible value, but it's not valid in the context of the problem, where if the problem's asking for time, you can't have a negative time. Verify if each stated root is a solution to the equation. So in a verification, what we're going to do is just take this, substitute it into here, and see if it's true. I like to do that by working out the sides separately. So I can say, well, the left side is equal to x plus 5 over x minus 1, which is 4 plus 5 over 4 minus 1, which is 9 over 3, or 3. The right side is 3, and say, yeah, that verifies. So, verified. This guy here, possible roots, 2 and negative 2. Well, we can see there's going to be a problem with negative 2, right? That's going to be a restriction, but let's check out the 2 first as a possible root, and then we'll look at the negative 2. Okay, let's go over here. So our left side, and we're going to try the value 2. I'm going to leave that as 2 over 2 because we're going to multiply by 2 over 2. So you get 2 over 4 minus 4 over 4, which gives us negative 2 over 4, which is negative 1/2. And the right side, So in this case, over here, the right side was just a number, but here it's an expression, so it's negative 2 over x plus 2, negative 2 over 2 plus 2, negative 2 over 4, negative 1/2, and that verifies. So it verifies that x is equal to 2. For negative 2, so we wrote that over here. We're just going to substitute in the left side. Well, let's do it here. Okay, x over x plus 2 minus 2 over x. Negative 2 over negative 2 plus 2 minus 2 over negative 2 is negative 2 over 0 minus negative 1. Okay, we got a problem. So negative 2 is not a solution. Okay, so in that instance, we were just verifying, right? We didn't actually solve. Now we're going to solve. Okay, here's a few to solve. So, step 1, factor the denominator. Okay, already done. Step 2, state the restriction. So x can't be 1. Step 3, lowest common denominator. So think of the 5 as 5 over 1. So this is already. And all we're going to do is we multiply through by the lowest common denominator. That's an x plus 3. Okay. So this step's a little different. We're not going for equivalent fractions. What we're trying to do actually is just get rid of the denominators. So this x minus 1 cancels here. And when we've canceled everything that we can, all we're going to have in the denominators is 1, 1, 1, 1. So we are left with x plus 3 is equal to, okay, so we'll clean it up first, and then we'll expand. So 5x minus 5. So move this over, you'll get 4x. Move that over, you'll get 8. Now I moved that to that side, and then I took the whole 4x over to the left-hand side. And we get x equals 2. So we check that against here, it's fine. We can try it up here. 2 plus 3 is 5. 2 minus 1 is 1. 5 over 1 equals 5. Okay, so that does work. So you can verify them yourself. Nothing to factor here. Okay, move the whole thing. But there is the non. So I'm going to write this as 6 over 1 because you need a denominator for everything. So a cannot equal 0, and our lowest common denominator is going to be 2a squared. And now what we're going to do is take each term and multiply it by 2a squared. So 6 over 1 times 2a squared over 1 equals 5a over 2a squared times 2a squared over 1. Okay, so this a takes out the squared. Okay, we're just going to have, and that becomes a 1. Got 1's here. The 2a squared takes out the 2a squared. So we have 3 times 2 times a, 6a, minus 12a squared equals, and that's all gone, equals 5a. So if we move this over, we'll get positive 12a squared, and we move this over, minus a is equal to 0. Factor out the a, and then say a is equal to 0, and say a is equal to 1/12. Now, the a is 0, that's a restriction, so we need to show it. We need to show that, hey, we solved this, and one of our solutions is a equals 0. And then we need to reject it, so we just take it out. So I'm thinking a is 1/12. Let's pull up our calculator, and we'll verify. So I'm going to clear my calculator. And here's how I'm going to do this, okay? So we'll work out the left side and the right side. We'll just do it on our calculator. Brody! So I'm going to go 1 divided by 12. And what I'm going to do is store that in x. So you see the little arrow up there, store. So it's going to work it out. It's going to put it into x. So if I just type x, I will just get back 0.8 and then repeating 3's. Okay, so the left side is 3 divided by, see, now I don't have to put in 1/12, right? Let's go 3 divided by x, and then minus, and order of operations says it'll do the division, and then it'll subtract the 6. So we get 30. And then we'll go 5x divided by, now I need to work out the 2a squared, so I have to put this in brackets, 2x squared, and then another bracket. Ideally, I probably should have put brackets around the 5x. I might just go back and do that, just to separate them out, right? To say, here's the top, the 5x, and there's the denominator, okay? And then I can hit enter. And we also get 30. So 1/12 verifies as a solution. Okay, this guy here. So step 1 is to factor. So 1 over 2 times x plus 4. So this is just a greatest common factor situation. Is 16 over 2x minus 16. Now, I can do a little bit of simplifying here, right? This 2 goes into the 16 8 times. So even before I simplify it, although it won't make any difference here, is let's get the restriction. So x cannot be negative 4 or positive 16. Okay, then we just have to keep those in mind when we go to solve. Our LCD, well, you need a 2. You need an x plus 4. And you need an x minus 16. So I'm going to take the first term, 1 over 2 bracket x plus 4, put that in brackets, and multiply it by 2 times x plus 4 times x minus 16. Equals, okay, wait, we changed that, right? So this is 8 over x minus 16 times 2 times x plus 4 times x minus 16. I'm squeezing. So the x minus 16 takes out the x minus 16. The 2 and the x plus 4 cancel out. So what I'm interested in is that's a 1. That's a 1. That canceled. That's a 1. Okay, what have we got left? So over here on the left-hand side, we've got x minus 16. And here we've got 8 times 2, which will be 16, times x plus 4. And we expand, x plus 16 is 16x plus 64. Move that over there. And move that over there. So we'll get negative, okay, 16, 20, negative 80 is equal to 15x. So x is going to be, all right, let's 80 divided by 15, 5.32. Okay, so 80 divided by 15, math, enter, enter. Okay, we're going to want our answer as a fraction, and that is 16 over 3rd. So, okay, negative 80 over 15, so x is negative 16 over 3. Well, let's find out if it is. So we can check this. So I'm going to take that and I'm going to store it in x. Now it's going to replace the x that was there. So probably if we just hit x, we'll just see 5.333. No, we see the 16/3. Yay. Okay, check this out. So here's some fancy stuff. If you got an 84, so if you go alpha F1, you can get into the fraction menu and say numerator over denominator. See how we've got a 1. Then you arrow over and go 2x plus 8. Okay, we can just hit enter, evaluate that. We get 3 over 56. Now let's go, oops. So alpha F1, numerator over denominator, right? So we've got this expression here. So 16 and 2x minus 32. Okay, and hit enter. Yeah, I love when It all goes according to plan. I'm going to leave this in. I don't care. I'm not re-recording. All right, let's take a look. What have we got here? So the 16, the 2 goes into 16, 8. That's an x minus 16. We've got a 2, we got an x plus 4, we got an x minus 16. Yeah, the 2's are gone, the x plus 4's are gone. We just have an x minus 16. Okay, so we have an 8 over x minus 16 times 2 times x plus 4. So 16. 16x plus 64. Oh, you know what? I didn't put it in as negative. Haha. Let's go back. Let's go negative x. Okay, store in x. Okay, so now I'm going to pop back up. And I'm going to grab the first equation. Hit enter. Okay, we get negative 3/8. And again, I'm going to pop back up. Bring that down. Hit enter. And we get negative 3/8. Right? So it is, in fact, negative 16/3, not the 16/3 that I first tried to check it with. Okay, so that does check. It verifies, right? And again, we're checking, make sure that it's neither 4 nor 16. Either of which it was. Okay, let's give ourselves some room here. So this is in factored form, right? Everything. I maybe put that as a 6 over 1. I like to write everything so it looks like a fraction. So x cannot be 0 and x cannot be negative 1. You can write it as two expressions, or you can just write the 1. And our LCD, so remember LCDs in this case is for getting rid of the denominator, not getting a common denominator. So x times x plus 1. So 4 over x times x plus 1 over 1 plus 6x over x plus 1 times x plus 1 over 1 is equal to 6 over 1 times x plus 1 over 1. The idea being, we do this right, we just end up with 1's in the denominator. Okay, so we've got 1's, only 1's in the denominator, so we start expanding. 4x plus 4. Okay, we got 6x times x, so plus 6x squared equals. So let's just treat that as 6x. All right, we'll get 6x squared plus 6x. Got a 6x squared on both sides. You can just cross them off. They'll cancel each other out, right? You'd subtract 6x squared from both sides. Let's leave the 4 here. We'll subtract 4x. So 4 is 2x, and x is 2. And that's not a non-permissive value. That should check. Let's just check by, by jumping out. Let's check by putting the 2. So 4 over 2 will be 2. And that's 12 over 3, which is 4. And you'll get 2 plus 4, which is 6. Okay. So I mean, you don't have to use your calculator to check. Okay. Put that over 1. So the restriction is that x cannot equal 1, and the lowest common denominator is x minus 1. So 6 minus x over x minus 1. They're binomials, like to put them in brackets. Times x minus 1 over 1 is equal to x plus 2 over 1 times x minus 1 over 1. Okay, x minus 1's cancel. I now have only 1's in the denominator, so we get 6 minus x is equal to, so this is a binomial times a binomial, so x squared, FOIL, minus x plus 2x minus 2. All right, collecting interest. So you notice I got a minus x on this side, I got a minus x on that side. I can cross those off. So we're going to get an x squared. We've got plus 2x. When the 6 moves over, it's going to be minus 8, and that's going to be equal to 0. So what if we try x plus 4 times x minus 2? So x squared minus 2x plus 4x is plus 2x minus 8. Okay, so x is equal to negative 4, or x is equal to positive 2. So those should both work, right? So if we put a 2 in here, we'll get 4. 6 minus 2 is 4. 2 minus 1 is 1. So that'll also be 4. Negative 4. 6 minus negative 4 is positive 10. Negative 4 minus 1 is negative 5. Positive 10 over negative 5 will give us negative 2. And negative 4 plus 2 will give us negative 2. So both of these are solutions. Just move this over. Things got slid a bit. Competing in an endurance race, Shannon cycled for 120 kilometers. So that's her distance, 120 kilometer cycle. And then swam for 12. Okay. Her average cycling speed was 8 times faster than her average swimming speed. If Shannon's average swimming speed is x, then her cycling speed is 8 times faster. It'll be 8x. Time. So time is distance divided by speed. So think about, I'm driving to Edmonton, 300 kilometer distance at 100 kilometers an hour. And that we know it's going to take us 3 hours. That's 300 divided by 100. So this time is 120 over 8x. That's the amount of time she spent cycling. And 12 over x is the amount of time that she spent swimming. And if it takes her 9 hours to complete the race, then that is the time she spent cycling plus the time she spent swimming is equal to 9. Solve the equation. Okay, we don't have a ton of room down here, so we'll just kind of continue on this way. So restriction is that x can't be 0. So this is a contextual question, right? If we end up with a negative value for x, we'll know that's wrong. You can't have a negative speed. So we'll say x cannot equal 0. Our LCD is 8x. I'm going to multiply everything by 8x. So 120 over 8x times 8x over 1 plus 12 over x times 8x over 1 is equal to 9 over 1 times 8x over 1. So 8x, 8x. X just takes out the x. So I've got a 1, a 1, a 1, a 1, a 1, a 1, all ones. Okay, so we're good. So this is 120 plus, okay, and the x is gone there, so that looks like 96 is equal to 72x. All right, let's get a calculator out. So 120 plus 96. So 216 is 72x. X will be 216 divided by 72, which is 3. So we are saying, what are we saying? What did they ask? Solve her average swimming speed, right? So swimming speed was x. So we can say her average swimming speed, her average swimming speed is 3 kilometers per hour. Now, what I like to do is just go back to the table here. Take the 3 with us, right? Now let's just figure this out. So she went 12 kilometers at 3 kilometers per hour. So it took 4 hours to swim. And 120 divided by 24 is 5. And it took 5 hours to cycle. So 5 plus 4 is 9. And I like to do it up here, kind of without regards to that. And then, we get the 9, we could say, oh yeah, it is 9. Okay. That's a good way to check a word problem. Okay. It's not the non-permissive I, it's not 0, and it is greater than 0. It's positive. Katie Burns. No, not her name. That's what she's doing. Katie burns 125 calories per hour more when she is running compared to when she is cycling. In one workout, she burned 690 calories on her bicycle. All right, so I think I can put 690 there. And then 1,260 on her run. If Katie burns X calories per hour when cycling, so rate of calories in cycling, and so she burns 125 calories more, so more is plus X plus 125. Write an expression for her average rate of burning calories when running. Okay, so that's just the X plus 125. Use the information to complete the table. So time. So how much time? So if she was burning, this is what I do, is I like to just kind of put in numbers and just say, all right, if she was burning 690 calories per hour, then we know it would take 1 hour, right? 690. What if she was burning like half of that? So half of that's 345. If I put a 345 in there for the rate, then we know that half of it means it's going to take 2 hours, right? And so it'll be 690 divided by 345, or the time, the expression is 690 divided by X. It's the total calories divided by the rate at which the calories are burned per hour gives you the total number of hours. What if she works out for a total of 3 hours? Well, then that is the 690 over X plus the 1,260 over X plus 125 equaling 3. Okay, it says solve the equation. Solve the equation. So X, excuse me, it's not a new cough. So it can't be 0 and it cannot be negative 125. Well, I mean, there's no way it can be negative anyways, right? Just in the context of the question. It can't be 0. You can't burn no calories, right? So that we know that X would have to be, contextually, we would say that X has to be greater than 0. Okay, not even equal to. But for our purposes, this is what we're doing. And the LCD will be X times X plus 125. So we take each term, 690 over X times X, X plus 125 over 1, plus 690 over X. Oops, no, that's 1260. Hang on, gotta find the eraser. Also got to start writing a lot smaller. Plus 1260 over X plus 125 times X, X plus 125 over 1 equals 3 over 1 X, X plus 125. Right. That's X plus 125. That's what's down there. Need more space. Okay. X's take out X's. 1, 1. X plus 125 takes out X plus 125. So the 3 goes with the X and the X plus. Okay, so let's do this. So 690X plus, okay, I definitely need a calculator. So we have 690 times 125. So 86,250, 86,250 plus 1260x equals, so we get 3x times x, so 3x squared, plus, and then 3 times 125, 375x. Okay, so we got ourselves a little bit of a quadratic here. Let's collect these terms while we're at it. So let's just go 690 plus 1260 is 1950. So 1950 50x plus 86,250 equals 3x squared plus 375x. Okay, 3x squared. So we've got the 375 minus the 1950, so we'll just bring that down, is minus 1575x minus this, minus 86,250 equals 0. Well, it would get a bit easier if everything was divisible by 3. So let's check divided by 3. Yep, and 86,250 divided by 3. All right, well, everything's divisible by 3. So let's go x squared minus 525x minus 28,750. 28,750 equals 0. Excuse me, I'm not even going to try and factor that. Same old cough. So x is going to be 525 plus or minus the root of negative 525 quantity squared. Just remember, this is always, b squared is always going to be a positive number. Minus 4 times 1 times negative 28750 all over 2 times 1. Got some space here. 525 plus or minus. Okay, let's go work this out. So let's go the square root of. Now, I'm squaring negative 525, but that's just 525. I can just square 525. That's not a square. And that's not in the right place. Okay. Root 5, that's not 5, 525 squared. Minus 4 times 1, okay, we don't need to go times 1, times negative 28750, 28750. Let's see if that just actually works out to a number, like 625 over 2. So x will be 525 plus 625 over 2, which is 525 plus 625. So let's just work those out. 1150, right, divided by 2 is 575. Or x is 525 minus 625 over 2. And so that's 525 minus 6 is negative 100. This would be negative 50. Okay. So with negative 50 is a perfectly fine solution to the original problem. But contextually, you can't burn calories at the rate of negative 50 calories per hour. Like, well, you can, sitting on the couch snacking, you might have negative 50. You'll gain 50 calories per hour, but you won't be burning. Okay, so we think x is 575. So let's try this out. I'm just going to get rid of this for a sec. So she burns 100. So we think she burns 125. So it's average rate of calories when cycling. So she burns. Here's our answer. She burns 575 calories per hour cycling. Okay, so that means that running will be 700, right? So you add 25 to that, it gives you 600, 700. So if we take 690 divided by 575, right? So that's the total time she spends cycling. And then 1260, I can go with the fancy, and if you don't have that, you can just use brackets. So I've got 1260 over 575 plus 125. And that should equal 3. I pressed the button with some trepidation, but yeah, it is equal to 3. Okay, so that does check, and that is a way for you to check. Okay. I was going to say last one, but it's not the last one. Second last one. I like this kind of... Okay, sorry. Oh, glitch. Glitch in the matrix. So she sold X minus 2 t-shirts. She kept 2 for herself. There are X t-shirts. There were 12 t-shirts in the case. Then she would have kept 2, giving her 10. So 12 minus 2 would be 10. Check with some actual numbers. Try some actual numbers. Write an expression for the amount she paid for each t-shirt. So if she paid $4.50, if she paid $45 for each t-shirt, then she would get 10 t-shirts, right? If she paid $10 for each t-shirt, she'd get 45. So the expression, the amount she paid for each t-shirt is 450 divided by X, right? So if she paid $45 a shirt, 450 divided by 45 is 10. If she paid $10 a shirt, 450 divided by 10 is 45, would be the number of shirts. So she paid $450 for all of them, and 450 divided by X for each t-shirt. Selling price for each t-shirt. So she sold them all for $5.60, but all of them is X minus 2. If she makes a profit, so she sold them for more than she paid for them, right? Like each price, the difference between the price that she sold them for and the price that she bought them for. So 560 over X minus 2 minus 450 over X is equal to 10. Solve the equation. Okay, so the number of t-shirts in the case is X, right? X. So we're solving for X. How many t-shirts were in the case? So we'll start here by saying X can't be 0 or 2. And really, there has to be more than 2 t-shirts in the case because she kept 2 for herself and sold the rest for $560, and nobody's paying $560 for an empty bunch of t-shirts. Our LCD is X times X minus 2. Okay, so everything's going to get multiplied by X times X minus 2 over 1, so 560 over X minus 2. 450 over X times X minus 2 over 1 is 10 over 1 times X minus 2 over 1. X minus 2's cancel. X's cancel. So 1, 1, 1, 1, 1, 1. All we have is 1 in the denominator. Let's go through. So this will be 560X minus, okay, so we got a minus 450X. Minus 450 times negative 2 will be plus 900. 10x is 10x squared minus 20x. Okay, here, let's do these two guys first. So that's going to be 110x plus 900 is 10x squared minus 20x. 10x squared. All right, this is going to come over. Minus 130x minus 900 is 0. Divide through by 10. Now, here's the thing. They're t-shirts, right? So there has to be a whole number of t-shirts. That means there has to be a number, two numbers that multiply to 90 and differ by 13. So we can just pull out our calculator and just try dividing. So 90 divided by 30. That's 3, so those numbers differ by 27. 90 divided by 20. It's 4.5, so 20 and 4.5 differ by too much. So 90, well, 19 is prime. That's not going to go in. 90 divided by 18 and 5. That's going to work. Okay, you could also use the quadratic formula, right? I mean, it doesn't really matter. So x minus 18. So that's minus because the larger number is negative. X plus 5 equals 0. So x is equal to 18, or x is equal to negative 5. This is inadmissible. You can't have negative 5 t-shirts. So there were 18 t-shirts. Shirt. Imagine that says shirts in the case. So go back to the words. She bought a case of t-shirts for $450. So 450 divided by 18, right? So she paid $25 for each shirt. I wonder if I can. That's better. Don't have a big bar there. She paid $25 for each shirt. She kept each shirt for herself, so $560, but she sold 16 shirts at $35. Difference between 35 and 25 is 10, so she made $10 profit per shirt. Two sisters. It's not a new cough. Two sisters, Amy and Britta, are responsible for raking leaves in their yard in the fall. Amy takes X minutes to complete the raking if she works on her own. Britta takes 25 minutes longer if she has to work on her own. If they work together, it will take them half an hour to complete. Determine how long it takes each of them when they work on their own. Okay, sorry. Bit of junk on the screen here, so just give me a sec. Clean that up. I had to back up a bit. Okay, so if it took Amy 1 hour on her own, then each minute she would do 1/60th of the work. Right? If it took her 100 minutes to do, each minute she would do 1/100th. So if it takes her X, each minute she does 1 over X of the work. Now Britta, working alone, would be 1 over X plus 25, right? However long Amy took, Britta takes 25 minutes longer. Now we know if they work together, so if we add together the fraction that they can do, it'll take them 30 minutes, which means working together, they will do 1/30th of the work each minute. Okay? 1/30th of the work because it will take them half an hour together. All right, so X cannot be 0 or negative 25, which would make no sense anyways, right? Based on the context of the question, 0 or a negative would make no sense. Okay, our LCD is 30, an X, and an X plus 25. So we are going to, so each term gets multiplied by 30, an X, and an X plus 25 over 1. Right, like to look like fractions. 1 over X plus 25, a 30, an X plus 25 over 1. 1 over 30, a 30, an X plus 25 over 1. So 30, 30, X plus 25, X plus 25, X. So here, 30x plus 750 plus 30x is equal to, excuse me, x squared plus 25x. Okay, so 60x plus 750, x squared plus 25x, x squared, let's move that over to me, minus 35x, move that over, minus 750. So really what I have now is 0 equals, but we'll just write that as equals 0. Now, probably this factors. It's not going to be actually the easiest thing to find the factors for necessarily, but I'm going to do it. So what we're hoping here is that it really does take a whole number of minutes for that to happen. So what goes into 750? Let's try 25. 750 divided by 25. So remember, the two numbers I have to differ by 35, right? And so 25 and 30 don't differ by. So let's go smaller, divided by 20. No. Divided by 15. 15 and 50, that's going to work, right? So if we go minus 50 plus 15. So 15 and 50, we just saw, they multiply to 750. And that, because that's a minus 35 and these differ, then the 50 has to be negative, right? So check. Anytime you factor, check. X squared plus 15x minus 50x will be minus 35x minus 750. So x is equal to 50. X is equal to negative 15. You can't rake in negative 15 minutes. So if Amy were working alone, 50 minutes. Rita alone, 75 minutes, right? So together, 30. So we would say, well, so 1/50th plus 1/75th should equal 1/30th. So let's find out as we relaunch. So 1 divided by 50 plus 1 divided by 75. And I'm just going to say, give me it straight as a fraction, so convert it to a fraction. And we get 1/30th. Yay. Okay, that's it. It's a long one. Sorry for the whining and the barking, but it's the way it is. This should take us up to the end of the first unit.